My name is Bob Plankers. I will be your speaker today. Thanks for coming. We'll get right to it. I'm a Linux systems engineer and virtualization architect for the University of Wisconsin-Madison. That leads me to have assembled a slide deck, basically a huge brain dump of notes that I've taken over the last 5 years for tuning Linux VMs. Thanks for coming. We're going to just cruise through this. It's hot in here. They are working on the AC. And I know you all want to get out and go take a nap or something before you party tonight. So I think we'll wait for questions. If there's questions in that, we'll wait till the end. If there's anything super wrong with my slides, please yell out that I'm a bozo or something. What we're going to start with, I'm making some assumptions with this slide deck. One of which is that you've got VMware vSphere. Well, I've got most of the stuff is developed on vSphere. It'll work fine. It'll work fine with vSphere 4 and 4.1. 3.5, you might not be able to do certain things, but I think you guys are smart enough to figure out what you can and can't do. Linux for me, Red Hat Enterprise Linux. That's what I do. CentOS 5, Oracle Unbreakable Linux, whatever you want to call it. You know, it's all frickin' Red Hat. So like did I say that? I'm sorry. Most of these techniques will work fine on Debian. I don't mean to diss Debian guys or Gentoo guys or Ubuntu guys or anything like that. But this is where I'm coming from. And I'm assuming you guys know something about Linux. I'm not going to tell you how to use VI or anything like that. That's a whole session by itself. I'm going to talk about specific OS level tuning tactics. Then I'm going to talk about some global tuning tactics from an OS perspective. But I'm not going to talk about reservations, shares, limits, all that stuff. The rest of the conference, you can learn about all that sort of stuff. And then I'll answer some questions. Again, just talking about the operating system. If you look at the whole stack, how the operating system interacts with things. Basically, tenets of tuning, inefficient VMs become slower VMs. Inefficient VMs they consume more resources. They hold more resources open, and I'm not keeping up on my notes here. Hang on. There. The slower workload runs, the longer it'll be holding. If that workload is doing something big in RAM, the longer it'll hold that RAM allocated, that sort of thing. So we want to get as much done per VM with the least amount of resources consumed. It is sometimes a trade-off, though, making a VM run really fast versus the environment's throughput. In a lot of cases, I'm after throughput. And we'll talk about that. One other assumption and bias that I should mention is there's, I'll just say it this way. A buddy of mine built a go-kart that could go 70 miles an hour, and the next thing you know, he's in the hospital. Tuning is like that too. There's a lot of stuff that you can do that is unsafe. It's like, don't try this at home sort of thing. If you can do it, it doesn't mean you should do it. I've tried to stay in the boundaries of sort of sane, good ideas, according to me at least. So, getting on with it. Partition alignment. Number one thing you can do to hose your performance is not follow your storage vendor's guidelines for aligning partitions. This is going to be interesting, pointing here. Misaligned volumes cause extra I/O, and I'm sorry, I don't mean to read my slides or whatever. I do have additional notes, but for the purposes of posterity, I put more information in the slides than I would normally. Anyhow, misaligned volumes. We've got logical block addressing. A long time ago, BIOSes used cylinder head sector sort of things. People invented hard drives greater than 500 megs. That didn't work anymore, and so logical block addressing was created. LBA basically shifts the beginning of partitions 63 bytes. And so you've got partitions at the VMFS level, you've got partitions at the VMDK level, for anything trying to be a PC, like a VM, is going to have this. So what you get is you end up getting these offsets. So you try to read that block. You can see I'm a little nervous. And you end up reading 2 blocks out of the VMFS. Actually, you end up reading 3 blocks potentially out of the, in this example at least, out of the array. I don't want to do 3 times the I/O. So every vendor, every storage vendor is different. Follow your storage vendor's guidelines. It doesn't happen everywhere. A lot of arrays will compensate for it. vSphere on many arrays will actually format the VMFS volumes. That your data stores will be formatted correctly with the right alignments. In Linux, if you're putting together a template VM or something like that, you may have to go in ahead of time before you do an install and boot into rescue mode or something like that and partition the disk ahead of time. You can just use fdisk, basically expert mode. Just tell it to align on something that's divisible by 128, and you should be good. Like I said, rescue mode booting is useful for that. It's great if you can do this to templates. If you have a bunch of VMs that are already misaligned potentially, NetApp actually has a tool, MBR scan and MBR align. If you run that, you'll just have to boot into rescue mode again and fix the bootloader. And certainly, if you have VMs that are misaligned and they're using logical volume management, that actually, you've got some other options here with PV move and things. So that's kind of nice. VMXNet seems obvious. A lot of people don't use it. Why? Well, we'll get to that. VMXNet is pretty cool. It saves CPU overhead. Most of you guys probably know this. Most of you guys are probably using it. The VMXNet 3 has a bunch of advanced features, a lot of TCP offload functions. It's got receive-side scaling. It's got MSI, the message signaled interrupts, where instead of generating an interrupt, it can basically put a marker out there for the CPU to pick up at its own convenience. That's kind of nice. Leads to some performance optimizations. Drivers delivered via the VMware tools. So install the VMware tools. The problems with VMXNet, what leads people to not use VMXNet, instead using the E1000 driver. E1000 is just pervasive. It's everywhere. Everything's got a driver for it. So why would you use this? Well, the performance enhancements are really nice. Kernel patching can disable the module. I had somebody tell me, well, that's not a big deal because we don't ever patch. Well, there's a bunch of ways to handle this problem. It seems there's always a tools upgrade available. If you patch the kernel, you can just plan on installing the new tools afterwards. If you want to stay with the same tools, you can rerun user bin VMware config tools.pl. There's some options there. You can go all the way to writing a script to detect whether they're loaded or not at boot and do some stuff. One of the easiest things to do, the VMware tools config.pl script has got a --kernel version that you can use immediately after. Kernel upgrades, kernel patches are just kernel installs. They're not like a replacement like the rest of packages are. And so what you can do right after the install, right after the update, but right before you reboot, is run the config tools with the --kernel version, and that'll fix up all of your stuff. Moving along, paravirtual SCSI adapters. Lower CPU utilization, that's really nice. Why wouldn't we want to save 30% of our CPU every time we do some I/O? Drivers are in VMware tools. They're installed by default. But again, patching can be problematic when the module doesn't load after an update. Yeah, and problematic, I mean like reboot and it sits there because it can't find anything. Yeah, that's sort of a problem. One of the problems with that then is that rescue mode boots. The default media from Red Hat doesn't have the PV SCSI driver in it. So not only are you really screwed one way, but then you're doubly boned. So I hope they're recording this. So like the VMXNet stuff, you can handle it after the kernel update. The VMware config tools, again, that's your friend. You could change /etc/fs tab. It's probably not, well, it's absolutely not recommended to use PV SCSI as your root file system technology, the technology behind your root file system. But if you're using it on high I/O file systems elsewhere, you could just change FS tab. I know a guy that's Actually has an elaborate system of grepping out the file systems that are in question, rebooting, then putting it back. It's like, that sounds like a big mess. Continuing with the big mess sort of category, you could build your own kernel. 2632 has got PVSCSI and VMXNet built into it, 2632 and higher, and that'll play into some of what Red Hat is doing. Red Hat's actually shipping Red Hat Enterprise Linux 6. Beta 2 is out, and they have the PVSCSI. As of Beta 2, they have PVSCSI as well. They've had VMXNet in all the betas. And so that'll be really cool. That will actually fix the fact that you can't use PVSCSI for your root file systems. So that's actually really good work. It's nice to see Red Hat helping us along. Continuing on, that was kind of the tour of the VMware tools. VMware tools are nice. They install They also install custom graphics drivers for X Windows and things like that. Not that I'm recommending X Windows. We'll get to that. The next stop is basically don't run anything you don't need. Seems obvious, but people just getting into Linux will often just click the install everything button. You get a nice graphical windowing system, X Windows, Xorg, all that stuff. It's really nice, helps you out when you're making the transition, but it sits there and uses a lot of RAM, uses a bunch of CPU. So if you're getting serious about this, you really want to cut down things that are using RAM, using CPU, cut down your surface area. You're also using a lot of disk, increasing your security profile. The more stuff you have running, the more stuff there is to get broken into, that sort of thing. You do this, check config will --list will let you see what you've got starting at boot. You can use check config to shut it off as well. You might consider keeping a number of things. There is an error, as was pointed out on Monday. CPU speed is a CPU scaling thing. That stuff is not exposed by ESX, so you can shut it off. And I'll publish these slides with corrections afterwards on my blog. I don't know if VMware will take midstream updates here. So things like port map and NFS, if you use it, cool. If not, then shut them down. Another thing that I've seen is people will start and stop those daemons when they need them, if they don't need them all the time. IPMI, LM sensors. IPMI is a hardware monitoring protocol and methodology. LM sensors is the same thing. Smart D, if that's running, you probably don't need those because you don't actually have hardware. So when you're doing this, one of the things is, like Red Hat Enterprise 6, we're in a really good position right now with Red Hat Enterprise 6 coming out and CentOS 6, and that we're going to get a fresh start. That's a really good opportunity to do a bunch of performance tuning, really make a nice template image. And so when you do this, if you're taking your template, just take what I like to do is take a snapshot of it, take good notes, so that later on I can try to figure out what I shut off because something's not working. Install fewer packages. Don't check the default everything. Sometimes if you don't know what you're getting into, just pick individual groups, but saves disk space. Pretty obvious. Disable X Windows. It's a big service, big set of services. Eats RAM. You can use it. You can run it manually. To disable it by default at boot. The concept of run levels. Run level 5 is full graphical multi-user mode. The run level 3 is full multi-user mode without the graphical stuff. So you can change etc init tab to instead of the line that says ID:5 init default, you just change it to 3 and reboot. It's also good command line practice. We all need good command line practice. NTP and timekeeping. Basically, this slide could be, I chose not to regurgitate the whole KB article, mainly because they keep it up to date. And that KB article, this is a big minefield. Every version, and I mean even like that KB article's got a table that's a mile long in it that has every conceivable distribution of Linux and even the subversions. It's got Red Hat 5 Update 2, Red Hat 5 Update 3, Red Hat Enterprise Linux 5 Update 4, 5. They're all different. And the recommended options change midstream. Red Hat says that they won't change anything between the release and the end of life. They're lying. And you can see it there. So when you're patching, when a new update comes out and major changes, read the release notes. Go back here because it's likely something will change. One of the things that, and the general trend, don't get me wrong, the general trend is that they're actually making things more virtualization friendly than they were. It still means more work on our part. So more recent OSs generally makes for better behavior. And NTP will keep the not only will the options there's an option called divide, a kernel option now called divider equals. It basically cuts down the number of times it's polling the timer, and it's really nice because it'll cut your Linux VMs down from using 300 megahertz of CPU by default to down to 30. Whatever you put in there is the divisor. So that helps a lot. Polling the timer is, by and large, pointless. Well, it's not pointless, but it can be done a lot less. We'll just put it that way. NTP then will keep the clock correct. That knowledge base article, by the way, right at the end of it has a really nice ntp.conf, ntp.conf sample. It's actually pretty good. You may want to change. I'm skipping ahead just a little bit to the bottom of this, but if you're not familiar with the NTP pools, if you're not running your own NTP server, you might want to check that out and just adjust the pools. Their default has some VMware pools in it, but if you're in Europe, you might want to use those, that sort of thing. It's kind of counterintuitive why you would want to shut the VMware. One of the recommendations from VMware themselves is shut the synchronization between the VMware tools, the time sync, off. And that's a little counterintuitive. Why wouldn't you want that to happen? Well, it couples, now you're coupling your ESX hosts to your VMs. So if you've got the time is wrong on one of your ESX hosts and you vMotion a VM over there, all kinds of stuff happens. B, the time can run backwards. It will set the clock backwards. Apps don't like that. File systems don't like it. There's this general concept we have as human beings that time moves forward. And we've built that assumption into a lot of things. And that's not cool. NTP fits, sort of futzes with the timer. It'll make slight adjustments constantly to slow down the clock if it's too fast, that sort of thing, but it won't jump it back unless you explicitly tell it to. So, disable the VMware tools. I believe it's off by default if you choose the Linux options, but if you choose the right OS. So, kernel parameters. I mentioned divider equals 10. Divider equals 10 is your friend. That's the recommended thing in the knowledge base. It cuts the number of times the interrupt timer or the timer is polled and saves you a bunch of CPU time. If you've got 300 VMs and don't want to go log into each one of them and manually edit grub.conf to add this as an option, there's a tool called Grubby, actually, that you can use. I've basically demonstrated some super crappy scripting there. You probably are better at it, but that's just sort of an example of what you might be able to do to automatically add it to your 300 Linux hosts and then reboot. Speaking of kernel modules, speaking of kernel options, you can also change the disk scheduling algorithms. CFQ, the completely fair queuing, is the default that's shipped. It's okay. Disk scheduling algorithms basically try to reorder disk queues. They maintain a write queue, they maintain a read queue, they try to optimize them for... they try to optimize them. I'll just leave it at that. And deadline, CFQ is one. Deadline tries to guarantee that certain operations will only take a certain amount of time, that sort of thing. Great on physical hardware. Mostly pointless on ESX and VMs because things that are upstream. ESX is screwing with your disk order, your disk queue orders, your HBA is messing around with them. The array itself is messing around with them. So why even spend time... CPU time trying to order this stuff? We can just set it to no op and just hand it off. So send it right up the stack and let the upstream devices aggregate it. If you're going to use Grubby, elevator equals no op is the argument you're looking for. Well, we're talking about disks, we might as well talk about ext3. One of the features, if you will, of ext3 is that by default, every time you read a file, it keeps track of the last time you read a file. One of the ways that feature really sucks is that it causes a write. And, so for every read we do, every time we open a file, we have to write something. Writes are hard for arrays. Well, they're harder for some RAID types than others, but I guess the point is let's stop doing that. If we don't have to write, let's not write at all. So they've got the no A time file system option. At mount time, you can choose to shut that off. There's also no dir A time. All you have to do is put it in the options column of the etcfs tab, and then remount your file system. If you're doing it to your root file system, in this case, a reboot is probably the easiest. As I point out, things may break, backups, monitors, all that stuff, but this isn't an all or nothing sort of thing. If your mail server needs last access time on, you can leave varspool mail if it's its own file system. You can leave that with it on and shut it off for everything else. So while we're talking about ext3, ext4 isn't quite as much of a follow-on as the name might seem, but it's pretty much a completely different file system. It's got a bunch of new features. You guys have eyes. I won't read it. Read the new features to you. That's boring. But I will say that Red Hat 6 and ext4 automatically align their partitions correctly, which is really nice. All of the I/O is aligned. And we need to thank the guys that are doing work with solid-state drives for that. SSDs have, even worse than just poor performance, they actually have life cycle implications. They will die, they will run out. SSDs can only be written to, the RAM in them can only be written to a certain number of times. So if you're writing to more than you need, you're going to kill your SSD faster. The air conditioning just came on, that's awesome. So ext4 is a good example of an optimization. There's a lot of other features in ext4. It's an example of a good optimization if we just use the latest OS available to us where possible. This is sort of a public service announcement. Use the most recent OS. They're getting more recent OSs, newer versions of Ubuntu, for example, Red Hat 6. They're going to have the built-in paravirtual drivers. That's going to be really killer for a lot of stuff. Better timekeeping. Every time there's a release, there's better options as far as, better things to save us CPU time. Tickless kernels are great. We'll get into that a little bit later. Basically, instead of pulling the interrupt timer or the timer all the time, the VM can just go to sleep and wake up and figure out where it's at. It's not using any CPU to keep its time. One other thing is hot add capabilities. Like Red Hat 5, for example, has got the ability to do hot add, and that's really cool. So I talked about tickless kernel a little bit, on-demand timer interrupts, and so instead of being in contact with the timer all the time, the VM will just go to sleep, then wake up, pull the timer. What time is it right now? Figure out what it needs to do. The mobile device folks invented this. When you're not running, when you're not actively running, you're saving power on a mobile device. Well, in a VM, you're saving CPU. So the more CPU we save, the more VMs we can cram on a physical host. Say power drive consolidation ratios up, no big deal there. Broken record, I point out that I'm going to keep saying use a newer OS, So mentioned hot add, great for right sizing. Application vendors love to tell you, you need 16 cores and a terabyte of RAM to run this web application, and you look at it and it's Apache and PHP or something like that. You need whatever. You need one core. To calm some of the application people down, you can say, hey, if you need more, I can add it immediately. Hot add is great for that, calming people down. And after the first time they see it, they go, oh, okay, I see what you're saying. No problem. Point out that it's hot add, not hot remove under Linux right now. So whatever you add, you better mean it unless you want to reboot. And UDEV is the Linux 2.6 device mappings manager, or device mappings manager. And while it might see the new RAM or new CPU, it might not actually put it into service, especially with CPUs. There's a knowledge base article. That knowledge base article is written for, I think it's like Turbo Linux or something like that, but it's applicable to Red Hat as well. They might as well just label it as all Linux. And it's a really easy tweak. You just change something to etc udev.d and then restart udev. The hot add also works very well for disks. I use this all the time. Somebody fills up a file system. I don't have enough space to do whatever they need in a volume group, so I just tack on another hard disk, another VMDK file, format it, or align it, partition it, align it, PV create, that sort of thing, and add it right in there. There's a rescan SCSI bus. You can also do this by catting stuff into certain sys files or certain proc things. This is really easy to tell operators, for example, and people you don't want messing around in sys. While we're talking about storage, we might as well talk about deduplication a little bit. I'm a NetApp user. I'm a proud NetApp user. I zero out my VMs all the time, and especially after patching cycles where we're changing a bunch of stuff. I'm sorry if this is your blog and you're sitting in this room. I've forgotten your name and I didn't put it in here. But this fellow right here has got an awesome zero out script. And the only thing that I would suggest adding to it, if you're using logical volume management, you're going to have some space in the logical volume manager that's not allocated. What you can just do is create a temporary LV, just dd dev 0 into that temporary LV, wait until it errors out because it reached the end of it, and delete it again. That works great for zeroing it out. If you're doing this, though, one thing you need to note is that this is in direct conflict with thin provisioning at the vSphere level. Thin provisioning at the vSphere level is change block tracking. This changes all the rest of your blocks. And so you will, if you had a 7 gig VM and you will have a 23 gig VM afterwards, or however much space this is going to consume. So you sort of, if you're a NetApp user, for example, or an array that has deduplication, you sort of have to choose where you're going to do the thin provisioning. I've chosen to do it at the array level. If you want to do it at the vSphere level, well, everything in this industry is it depends, or depends on your situation or something like that. You make the best call. So there's all these options out there. There are also some performance implications to doing thin provisioning under vSphere. You get a lot of fragmentation in that too, so you might choose to just skip it completely. We're going to bounce around a little bit. Like I said at the beginning, this is sort of a brain dump, and this is how I think. It's kind of scary. Network tuning. Network tuning is a big topic, and we could talk at length about it. There's a couple of things a couple of key concepts you should be familiar if you're going to be familiar with if you're going to mess around with network tuning. Basically, a big pipe. Imagine this example always gets some cringes, but the main sewer pipe between my house and the road is 6 inches. 6 inches in diameter, I think, and it can hold, and it's 40 feet long. It can hold a fair amount of water, as I found out last fall. And the trees, and the same is true of network links. They a big fat pipe, a 10 gig pipe that's and you measure the distance really in milliseconds. That's 200 milliseconds long, can hold a whole bunch of data. And so you want to adjust your TCP windows, and this is where receive side scaling can come into play. But there's some OS level things that you can do to tune that. Rather than getting into all of that stuff, there's a couple of reasons we don't need to talk about all of this right now. One is because, actually, and this is another error, I'm sorry, everything 268 and up auto-tunes. So the Red Hat 4 and 5 has auto-tuning on by default, your window sizes and stuff like that. You can shut it off if you want. The other thing, too, is the Pittsburgh Supercomputing Center has for years maintained probably one of the best references out on the internet for tuning TCP stacks. And they've got Solaris, they've got Linux, they've got Mac OS, they've got Windows, all that stuff. And so that's a great resource. With the top one, of course, comes the broken record, the idea that you need to use, in order to take advantage of some of these things, you need to have a recent OS. I'd also like to point out that there's other types of auto-tuning available to us. Sorry, that's a terrible joke. But this also marks sort of a shift in the presentation. So those are some things that you can do on a VM level, some specific things that you can do to tune VMs for better performance that will help you not only on the VMs themselves, but help you sort of holistically get better throughput in the environment. So I'm going to talk a little bit about some strategies now for tuning that may not involve, actual changing of files. And it'll involve changing of files and things like that, but it's more strategy sorts of things. We've got about half an hour left. So the idea in environment-wide tuning is that resource contention. We want to remove resource contention. If we've got 300 VMs running on 20 hosts, like anytime they do something all together, you're going to have resource contention. Fewer VMs when you've got these situations. Slower VMs when you've got these situations. Your phone is ringing, people are pissed off, all that sort of stuff. So we want speedier VMs, and we want to continue trying to have more VMs per host. So one of these things, like I mentioned, anytime VMs do things all at the same time, you can get into trouble. Cron tab is a great example. You've got all these default cron entries, especially if you check the everything button when you installed. Packages are notorious for sticking stuff in cron. You probably got monitoring systems. Monitoring systems kick off every 5 minutes. That's probably a necessary evil, at least according to our bosses. The log rotation, though, do you really need, at 4 a.m., all the logs rotate. Log rotation often uses, depending on how you set it up, you can have it compress and rotate. You can have it copy or just move the file, truncate the file, all this stuff. You start asking questions, can you do it through a central scheduler that's more VM aware, that often uses a third-party piece of software? Might be expensive. A central scheduler is kind of annoying. One thing I do, I've chosen the log rotation as an example. We don't really need 4 a.m. for all of the logs to rotate at 4 a.m. It could be 5 or 6 a.m. It could be, whenever. As long as they rotate once in a while, that's fine by me. So I just booby-trapped the shell script that does the rotation, Bash has got the $random, and random will return a result that's 0 to 32,767. And then if you want 5 minutes, you just can figure out what your divisor is. I think this might be, I don't even know what that is. I can't remember. These slides were submitted about a month ago. So but that's a good simple way. You just put this right at the top of a shell script, and you've got a little bit of load distribution. Etc cron, there's a whole bunch of etc cron directories that have things in them. Like I point out, packages are sneaky. They will stick stuff in there all the time. You may not know about it. You might want to go and check and see what's in there. mlocate is a good example of something that's there. mlocate is kind of handy. If you're not familiar with it, it'll go through and index all of the files. So you can just type locate space, document name or whatever, and it'll find it for you, maybe, if it's there. It's just basically a big searching thing. But in our environment, it was on everywhere, and we didn't need it. We need it probably once a year on each VM. And so there's nothing stopping a sysadmin from just running the update command manually. It takes maybe a couple of minutes tops. And so we just took that out of the cron tab. And mlocate actually has the idea. It's nice because it's got the concept of a stale database, so it'll actually warn you that the database is more than 7 days old. So that's actually kind of cool. Backup scheduling is another great way to use a lot of CPU and RAM and all that stuff. And backup windows, if you can get sort of creative with your backup windows, that can be really nice. Out-of-band products are kind of nice. Where you're not even because they actually understand VM environments usually better, and we'll do better things with that. But even like Tivoli Storage Manager lets you on the server side change how many clients can start at a time, and that sort of thing. So you can tweak that so you only get 1 or 2 clients going simultaneously. You could also, if you're sort of questioning how you're doing it, you could also maybe do backups throughout the day, on if it's becoming a low-level process and not using a whole lot of resources, you can potentially do different things with it. So I'm just throwing it out there. It might be applicable to your environment. It may not. Service monitoring systems. Every check is load. And I've seen some people write some really crazy checks. And, I'll just leave it at that. Don't do anything more than you need. And a good friend of mine loves to say, don't check for a condition you're unprepared to handle. Don't throw an error you don't know how to deal with, good advice for life. The performance monitoring systems. This is another thing. Don't check the performance from the VM. We've got a performance, where I work, we've got a performance monitoring system. Actually, it's still running on all the VMs, but and our app admins love to go look at it. Oh my God, we're using all of our CPU. From in the VM, it can't tell how much CPU is allocated to it. You don't know those sorts of things. The vCenter metrics, the vCenter performance tab does. ESX top does. ESX plot is useful for that too. Systat and SAR are great performance monitoring tools, especially in physical boxes. And they can also monitor things from the OS, memory, and things like that. But they're one of those sneaky. They're one of those sneaky packages I was talking about, sticking stuff in cron. And so it's got a service and it's got cron tab entries that will sit there and monitor stuff. Well, if you're already collecting this data, how many copies of it do you need, and how many incorrect copies of it do you need? So what I've chosen to do, I shut it off, and rather than just deleting this file, one pitfall, if you just delete that file, the next time you patch, it'll come back. If you edit it, you'll get an .rpm new there. If it changes it, the package manager will see that you've changed it and will usually respect that. But like I said, if you delete it, it'll come back, and then yeah, go for it.
I did something like that in cron directory and it ended up running both of them, so it'll run the new one too. That directory is probably fine if you have it in one of the dailies and the hourlies don't work.
I see what you're saying. So basically, the moral of your story is that this may not be the complete guide to eradicating SAR. Okay. So I'm not saying that I don't have mistakes in here. I'm totally cool with that. This is not the compendium of the end-all compendium of tuning tips. Do work elsewhere. This is kind of goes in the question assumptions category. We're changing everything about virtualization. Why don't we do work somewhere else? Is it cheaper to do log processing on all of our hosts, or is it cheaper to buy a box to do Splunk? I don't know. I got a little hat tip to the shout out to the packet pushers guys with the where do you terminate SSL connections. They were pointing out that a load balancers and network equipment often has specialized SSL stacks in it that are better tuned for performance, and that they can be up to 40% faster than your native random untuned stuff that might come with an OS distribution. So, if you're doing a lot of SSL, you're doing a lot of web traffic, it might be cheaper to use one of those rather than doing the SSL locally on all the hosts. I guess it depends on your host, depends on your environment, but just throwing it out there. It speaks directly to the budgets, So we'll get into a little bit of VM sizing, back to the VMs themselves. as a sort of a holistic strategy, don't listen to the application vendors. This is not, dude, you're buying a Dell. This is, dude, I'm giving you exactly what I think you need to start with, and then we'll adjust it in a few days, months, years when it changes. I know why app vendors do it. I'm sorry if you're an app vendor and I'm ripping on you right now. I really don't mean to. It's you want the best. App vendors truly want the best experience for the customer, and they don't want the hardware to get in the way. So I get that, but yeah. Want to develop your own experience with an app, watching it, some people put apps on special or on separate hardware and separate run it on a VM on separate hardware, keep an eye on it, and then pick a time in the future to right size it. Hey, you asked for 8 gigs of RAM, but I noticed you're using 512 megs of RAM. Could we give you a gig, maybe? Going whole hog, and if they're using 512 megs of RAM, cutting them down to just that can actually be a little bit dangerous. One thing that or can actually hurt your performance. One thing to note is that file cache, unused RAM is used as file cache. OSs have been doing this for a long time, and it's a neat performance optimization. Basically, it cuts down on your I/O. And so trimming all of your file cache out of a VM, OSs are better at figuring out your file cache or the caching needs than ESX is at right now, or at this point in time. Apps, like if you've got apps, actually apps should know better about their caching needs than the OS even. Software like databases, Oracle, for example, rather than giving your RAM to file cache, you might want to choose to give it to your database instead. One thing about native performance monitoring systems, this kind of speaks to that, and also the RAM here. This line, if you can see it, sorry, the contrast sucks, yellow on green at a distance here, but no one said this was going to be aesthetically pleasing, I guess. But this line right here is the file cache. So this box in particular, the green here, it's using all of its RAM, but it's using the bulk of its RAM for file cache. That's cool, Well, it's not cool. It's cool if you meant to do that. It's not cool, well, if you didn't. It's also not cool when, it seems obvious. Sorry. So this space here is really what the applications are using. There's a little bit in there for buffers and stuff like that. Actually, the purple on the bottom is buffers. But one thing to consider here is that this is another pitfall of monitoring systems on hosts, is that when my application folks take a look at this, they go, oh my God, we're out of RAM. Oh my God, we're out of RAM. No. Yes, here's a CS book, come back later. So OSs know best what to cache. And like I said, the apps actually, if the apps are into cache management, they actually know more about what they need to cache. Don't overcommit your don't overcommit your RAM and stuff like that. Paging at the ESX level hurts. If you have to cut things down, do it. A little extra I/O is a heck of a lot better than paging. If you're RAM constrained, paging sucks. And you need to find a balance, basically, file cache versus I/O versus your consolidation ratio. I know in my environment I'm really RAM heavy. In fact, I can't build a box big enough to, people just eat my RAM, so this gets weird. But read-ahead services are something that are installed sometimes. They basically, by default, they preload things into the file cache. It's great. What they're preloading is X Windows stuff by default. If you're shutting X Windows off, shut X Windows off. Maybe I'll say it again, shut X Windows off. You probably don't need them. You could also wait an extra second or something like that for them to load. It's a trade-off. You could also mess around with the preload scripts to actually load something you want to be in file cache. Weird concept, I guess. VM sizing for CPUs, I lead again with app vendors CYA, they may not need what they're asking for. And it's a little counterintuitive sometimes. VMware sometimes a 1 CPU VM can run a heck of a lot faster than a 4 CPU VM. And that's just the way it's scheduled. ESX, every new version of ESX helps this. They've got relaxed co-scheduling now to try to detect when a 4 CPU VM is really only using 2 of its CPUs. It can get scheduled. But, if you, especially in resource constrained environments where you've got maybe a dual socket, dual core machine, and you've got some 1 CPU VMs and you've got a 4 CPU VM, that 4 CPU VM has to wait for all 4 cores to be available in order to run. Potentially, there's relaxed co-scheduling and stuff like that, but that means it's going to take a while. Those 1 CPU VMs are always able to run as something frees up. So it's sort of a competition. I've seen a number of cases where just reducing the number of CPUs boosts the performance immensely. And one of the things about vSphere 4 introduced the idea that you can have there are options other than 1, 2, or 4 CPUs. 4 CPUs. And you can have 3, you can have 5. Only add the number of CPUs you really need. I've got a whole bunch of 3 CPU VMs, and that's pretty cool. You can tell, one other note, I said I wasn't going to talk about more environment stuff, but you can tell when this sort of thing is happening in ESX top. The percent ready column will have, it'll be high. That percentage, basically it's ready to run, but it isn't running. So when that's really high, that means it's waiting for something. It's usually waiting for resource availability. Host sizing. Bigger resource pools, better VM scheduling for that same reason. And you might choose, 3 bigger hosts because you can have 32 cores in them or AMD 48 cores in them versus, just having 8 cores or 16 cores, something like that. Do you want more cores or faster cores? More cores are actually helpful in a lot of ways. And then load balancing versus VM size versus host size. Is it better to have 2 giant VMs load balanced, or is it better to have 10 smaller VMs load balanced? Yeah, I don't know. It's really up to you. Well, and that's a management thing too, That's where your management tools come into play and your practices and stuff. So, speaking of practices, some tactics that have helped me with all of this stuff, having a regular patching schedule. Having a patching schedule at all is nice. It keeps you secure, allows you to do controlled changes. You can actually roll out some of the stuff in a controlled way. And it helps you get the latest code on there. Full virtual test environment. I'm blessed to have a full test environment that I can say, hey, this is mine, and I can mess around with it. Even a workstation is really nice for this sort of thing. Anything with snapshots, if you're doing VM development and stuff like that, template development, snapshots are absolutely killer. And I'll just leave it at that. Other tools that have helped, these are tools that you can run locally on the VMs. IOstat, you can see actually what the VM thinks it's doing for IO. That's nice. VMstat. ESX still can't see into the VM to see what's using RAM and not, so you're still going to have to use a local tool for that. PowerTop. I will talk about PowerTop and Ktoon in a little bit. IOZone and Bonnie++. I've got Bonnie++ on all of my hosts. And it's handy just to, when somebody reports slow disk performance, they never actually mention disk. My VM is slow, like it's slow disk or whatever. I can see what's going on with that. But Ktune's actually pretty cool. It's a great starting point for tuning. It's a package you can install under Red Hat 5. It's got good new default settings for network tuning, for example. It will also it'll adjust your elevator to be deadline. You can go in there and change it to no op. No big deal. PowerTop, this is one of those laptop things. This is actually an Intel project, and that which is good for laptops is good for us too. And it'll make some suggestions to you. Here you can see some of these suggestions are totally usable. Some of them are completely ridiculous in an enterprise setting. But again, it's looking at it from a laptop mobile device perspective. Wake ups per second is like 193. It's probably because I'm running. It appears that I'm running X Windows on this, which nice shot, huh? Other stuff. The other stuff. This is sort of my dump at the end slide here, because these presentations are submitted so far in advance. The talk on Monday, actually, somebody asked about a lot of the proc tuning and stuff like that, VM swappiness and things like that. You can do a lot of tuning in there to change how quickly the file system cache will write writes and stuff like that to disk, commit them to disk. You can do a lot of messing around with that. High watermarks for file cache, low watermarks. You can actually, pin the file system cache to a certain amount, that sort of thing. That kind of goes with my go-kart analogy earlier. There's a lot of stuff that you can do there, and actually tuning like that is an immense topic. The defaults are pretty decent, and unless you really have, in my opinion, and take it for what it's worth, I have no idea what it's worth, and the defaults are cool unless you really have a need for it. It's my opinion that you don't really want to mess around in there too much. Plus, I'll just leave it at that. So what to do with all this advice? My suggestion is implement it in your template VMs. Red Hat 6, like I said, is a great fresh start. You're going to get a chance to build a brand new template VM. And it'll be a couple of years until you get a new OS and a new excuse to do this again. So make it count. Test all of the stuff first. Like I said, some of these things will actually break stuff. Try to figure that out, but a lot of these things, it's not all or nothing. A lot of these things will degrade gracefully, fail gracefully. So the VMs you got running right now are probably the ones that need tuning the most. So if you've got a regular patch schedule, you might want to try to find ways to, even if you can't do all of it, just getting started is a good, start somewhere. You can't get anywhere unless you actually start. So questions, comments? I suck. What's going on? And before everyone leaves, please fill out, I'm supposed to pimp the surveys. I'm awesome. There's a column for that in there somewhere. No, I don't know. Please be honest. But please fill out the surveys. I believe you can, I don't know if you can do it online or not either, but you can do it online. Thank you. So questions, comments? Yeah, what's up? Thanks, guys. Yes. Dev random and urandom, ESX doesn't expose some of that stuff to, there's some features in hardware that will help with that. What we've actually been doing, I believe it's called RNGD. There's a daemon to basically help seed things, and we've been running that and seeding dev random and urandom with, I'd have to look at our config, but RNGD will help with that. Generally, when we've seen it, it's basically because stuff is blocking because there's not enough entropy, and that's how we fixed it. Physical hosts are nice because they get entropy from the network stack and stuff like that. Things and hard disk seeks and all kinds of stuff that don't happen in VMs, and so that's a really good point. I don't have a pen, so. If that helps. Okay, cool. Yeah, what's up? No. They don't have to spend money. These are direct tactics. With a regular patch schedule, you can implement things like this, and there will be more over time. And they don't have to spend money. Upper management loves not spending money. They don't have to spend money to augment your environment if they let you patch once in a while. Well, that's a different thing, depends on how far out you want to go, Red Hat, for example, guarantees, to the extent we've seen, guarantees that things will be compatible from the same stuff, the same interfaces will be available from beginning to end of the life cycle. And so they also guarantee that things won't break between Red Hat 4 or Red Hat 5.4 and 5.5. We know a little bit differently, obviously, but this is where test environments come in too. Hopefully your app guys have a test environment that they can try this stuff out on that you can patch ahead of time. One of the things that we do when we're patching is that we've got a month-long window. We do all of dev and test in the first 2 weeks and do all of QA and prod in the second 2 weeks. And then we split load balance clusters between the 2 weeks, so we only do half of a dev and test load balance cluster the first week, And I mean, some app people don't like that, and so we futz with the schedule a little bit. But that way, we only potentially break half of their cluster at once. They can do their testing, that sort of thing, and then we learn. Actually, usually, lately, it's been a 5-week schedule. There's a week of like trying to just resting in there. So. Yeah. Well, what you need is just a good security vulnerability once in a while, like Windows has to, and once in a while, I mean every Patch Tuesday. I kind of envy the Windows guys sometimes. Well, I don't, but but they're forced to have these windows all the time, and so that's helpful. I think you had a question. I haven't extensively. I know other people have, but I really haven't done a whole lot with XFS and stuff like that. So, no. I know EXT. I'm looking forward to EXT4 because it brings a lot of those same concepts that XFS has had for decades, and probably decades now, to something we're actually using by default. But I used an SGI a long time ago. That's about as close as I got. For monitoring, we use Nagios for the normal checks. Actually, I'll just say we use Nagios. We've got a hacked up version of Big Brother from like 1922 or something like that too, that we're replacing wholesale with Nagios. And we are for performance monitoring, we run the Orca stuff with a stats gathering script on our hosts. Like I said, I did mention that I'm not following my own advice. We're still running that on all the VMs right now, but it's not going to be very long. We're getting, our Linux and hosts are 95% virtualized, so I think that'll be impetus to break and be able to separate physical from virtual now and say, you know what, we don't need this on that. So, but if that answers the question. Yeah, what's up? I have not, no. Okay. Okay, so for the recording, I'll just repeat what you said. Red Hat's got a new tool, Zero Free. What does it? Is it something that is separate, or is it shipping with 6, or? Okay, it's shipping with. Okay, 5.5 and 6 have got it. Okay, cool. Thank you. I have not heard about that. Yeah, what's up?
My baseline is 64-bit kernel with SMB kernels.
Mm-hmm.
Situations like when I have to run a 32-bit JVM, does that negatively affect that?
No, I can't. Like, unless you know otherwise, I can't imagine why it would affect that. I mean, 64-bitness is mainly due to memory addressing. There's probably some performance differences, but.
Is it beneficial? Is it wasteful for you to be doing that?
I don't have a good answer. It's probably, there's nothing that I've ever heard of that says that it's so grossly wasteful that, so I'm kind of inclined to trust my own, not even hearing about it, that it's like this big thing. But somebody might have a knowledge base article about it. I really don't have a good answer for you. Sorry. Yeah, what's up?
Do you know if we can get any I/O performance if the whole OS is on LVM, and if we do the MDR scan from that out, it does not recognize anything with it?
Yeah, that's one of the problems with using LVM. LVM is great, but MBR scan and MBR align, that's a good point. Doesn't recognize that as file systems. Neither does the VMware converter see the logical volumes, and that sort of stinks. What I've done with sort of stinks is an understatement. What I have done is actually on my VMs that are misaligned, I've chosen rather than aligning the whole disk file, I add another hard disk, partition it correctly, align that, and then PV move all of the base volume group over there. And I just, so my file system structure is, I've got a /boot, that's its own 200 meg partition, and then I've got a PV for the logical volume manager. And so I can just PV move that whole PV somewhere else. We're not really writing to boot a lot, so I don't care, I really don't care if we're not doing very efficient I/O there because, well, we shouldn't be doing I/O there much at all. But the stuff we are doing I/O to, I PV move that somewhere, fix the partition table back on the main disk, reboot to pick up the new partition table, then do PV create and all that stuff, and then PV move it back and get rid of that extra disk. That's what I did with it, and that seemed to work pretty well. So. Yeah, PV move actually is cantankerous sometimes. It'll stop in the middle. I haven't had any problems as far as being able to restart it or anything like that. But yeah, it can be a little odd. And if it's one of those things, if you take a snapshot, you're basically moving all the blocks on disk, so your snapshot's going to get huge instantly. But a snapshot also might be a great way to recover quickly from that too. So you just trade-offs. Yeah, what's up? LoneSysAdmin.net. I've been a little shy about shameless self-promotion, but that's my blog. So I will put them up there. I don't know if VMware will let me update this presentation, and I don't know if they're going to post the notes. And then I've got additional notes than were in here. What's up? LoneSysAdmin.net. So cool. Yeah, what's up? Oh, yeah. Yeah, just the zero block reclaim and stuff like that. Yeah, well, and that's one of those things. I mentioned what I do with NetApp, and the zero free thing is cool, and it's one of those things that, one of those areas of this presentation where it's like just sort of an idea, a starter for ideas. If your vendor offers that sort of thing, they'll often have recommendations for how to do it too, except NetApp didn't seem to have any for me. So, yeah, what's up? Oh, yeah.
But I was wondering if you could elaborate a little bit more on what you found as far as performance improvements using it over CFQ, and also, in addition to that, what is Red Hat's feeling? Is there not a big solid kernel out there?
Yeah, I think my commentary in this regard is going to be substandard. This is one of those things that I've been doing it for so long, I've forgotten where I saw the idea to do it. And I really haven't done any performance testing on it. I/O queue restructuring is probably not a CPU intensive sort of thing. It's one of those certainly things. There are certain things in this presentation that are definitely more heavy hitting than others. No A time, for example. If you had to choose one to do, no A time might be a lot better to do than no op. But yeah, I don't really have a good answer for you. I'm sorry about that. As far as like performance testing, you could do it and post it on your blog.
Yeah, absolutely.
So.
I guess from our perspective, if that's something that had a positive influence, we'd like to get Red Hat to recognize
Make it the default. Yeah, a lot of these OS vendors are still bridging the gap. There's a lot of stuff you can do for VMs. There's a lot of stuff you can do for physical boxes, and they sort of have to, they're still defaulting to physical boxes. It'd be really nice if they had, like, at install time, like, hey, this is a VM, do the right thing, Pardon me? Oh, Ubuntu has that. That's pretty cool. I wish I were running that. Yeah, Ubuntu, given their release cycle, actually gets a chance to do some of these things more often than Red Hat does, given that Red Hat waits 3 years between releases and stuff. So, cool. Yeah, what's up? I missed the last part of what you... Yeah. Oh, how do we keep them the same, given that, with Linux, Red Hat channels are basically moving target sort of things? We actually use Red Hat's satellite server. So what we do is we clone the channels to be a specific point in time so that they don't drift like that. And that the main channel will continue updating and get the new packages that'll happen during that month or so, but we'll always be applying the same thing to all of our hosts. And then when we go to patch, we patch twice a year, and it's a giant operation. I harbor no thoughts that patching isn't a giant pain, but it also is a good way to keep secure and do stuff like this. And you do it enough, and you get better at it, and people get used to it and stuff like that. And so that's just one of the ways that we've chosen to do it, is just freeze it in time, and then in 6 months when we do it again, we'll just freeze it again. So, okay, enjoy the party tonight, you guys. Thank you.